Howdy, this is John Engstrom with TDI Technologies. I'm here today to talk about the basics of public key infrastructure, or PKI, what it is and what problem does it solve. Let's take a look at the initial problem with sending data from one point to another over a unsecured medium. We have Alice, who wants to send Bob her credit card information. Maybe she's buying something from Bob and wants to send him her credit card to get charged. We have Alice doesn't want anyone else, obviously, to see her credit card information. Here we have Alice, and here we have Bob, and here's her credit card. Alice has that on her person. She wants to be able to send that across an unsecured medium to Bob. Maybe it's from one side of a stadium to another and she's going to yell it out, or maybe she's transmitting it across the internet. Here she goes sending it, and our nefarious man in the middle, Malcolm, appears, copies her data, and then he disappears. Bob gets the original data that's sent, and nobody is any the wiser that Malcolm has stolen her credit card and will use it to charge up unexpected charges. Well, that's obviously no good. So, let's see how to get around this problem. We have solution number one. That involves symmetric keys, which symmetric meaning it's the same key used to encrypt the data as decrypted. So Alice is going to use that key. She's going to encrypt her credit card with the symmetric key. Then Bob, who gets that encrypted data, is going to use the same key to decrypt it and get the credit card number back. Here we have Alice, and here we have Bob, and here we have Alice's key that she's going to use. Now she sends this key to Bob, so he has a copy of it, and then the credit card from Alice that she keeps on her person, she's going to use the key to encrypt this credit card and turn it into an encrypted value. She sends that encrypted value across the unsecured network. Malcolm, our nefarious man in the middle, gets that encrypted data, but because it's encrypted, Malcolm doesn't know what to do with it. So he packs up and leaves without copying or doing anything. Meanwhile, the encrypted data gets to Bob, who uses his key to decrypt it successfully and get back the original credit card information. So that's a great solution. And symmetric encryption is very strong encryption. It's very hard to do a brute force attack on it. It's very fast to encrypt and decrypt data using computers. So overall, it's a pretty good solution, but it does have a problem that I'm going to illustrate here, and that is the transfer of the key. Malcolm can intercept the key and use it to decrypt Alice's credit card. So here we have Alice again, and here we have Bob, and here we have Alice's key that she's going to send to Bob. Unfortunately, if she has to use an unsecured medium to transmit that key, for example the internet, then Malcolm can appear. He can copy that key, and then he and the key can disappear. Now, anything that Alice encrypts with that key will be readable by Malcolm. So, that's not good. How do we get around this problem? Well, I'm going to take a minute and I'm going to talk about public-private keys, what they are. Public-private keys are really nothing more than just a complex algorithm involving really large prime numbers and some, big brain math stuff that some really smart people came up with to generate a pair of related keys. The data that's encrypted with the first key in the pair can only be decrypted by the second key in the pair, and conversely, the data encrypted with the second key can only be decrypted by the first key. So here we have our generated key pair. We have a blue key and we have an orange key. We send those to their respective corners, and we have some data that comes in. We're going to make this the credit card number. we're going to use our blue key to encrypt this credit card. And we come up with an encrypted value that only the orange key can decrypt. If the blue key tries to decrypt it, then the decryption fails. So we send this value over to the orange key, and the orange key is able to decrypt it, turn it back into the original credit card number. So let's suppose we have that credit card number come into the orange key. Now we're going to use the orange key to encrypt the credit card, and we come up with an encrypted value that only the blue key can decrypt. If the orange key tries to decrypt the value that it just encrypted, it fails. So we send that encrypted value on over to the blue key, and we decrypt using the blue key, and once again, we have a successful decryption and the original credit card information. So, let's go ahead and take this concept of a key pair, and let's apply that to our initial problem, and let's see if we can come up with a solution. Call this solution number 2. Bob sends Alice his public key, and he's got a key pair that he's going to generate. We're going to call one of the keys a public key, and the other key in the key pair is going to be a private key. Alice is going to use that key, Bob's public key, to encrypt the credit card, and then she's going to send that credit card to Bob, who will use the other key pair, the private key, to decrypt the credit card. Let's take a look at how this works. We have Alice, and we have Bob. Bob has a key pair, an orange and blue. We're going to call the orange key Bob's private key because Bob is going to keep that very secure. He's not going to share it with anyone. He's definitely going to make sure it's protected and can't get copied, and so it's a private key Bob is the only one that has access to. The blue key is going to be the public key. Bob is going to distribute that to anyone in the public that wants to communicate with him. In this situation, he's going to send it on over to Alice. But Malcolm, our nefarious man in the middle, can copy that key and leave. And we'll see why this is not a problem here in a minute. Because Alice is going to take that key and take her credit card, and she's going to go ahead and encrypt her credit card using Bob's public key. Now she comes up with an encrypted value, and the only key capable of decrypting that value is Bob's private key. So she can turn around and send that encrypted value over a public network like the internet, and Malcolm appears, and Malcolm only has a copy of Bob's public key. So if he tries to decrypt that value using the public key, it's going to fail. Malcolm is, confused and thwarted, and so he leaves. Meanwhile, the encrypted value from Alice goes to Bob, who can turn around with his private key and decrypt it, turning it back into the credit card information that we keep secured. I hope this has enlightened you, and now you have a better idea of how public keys and private keys work. They're really just key pairs. Public and private comes from whether you share that key with the public or whether you keep it private and don't share it with anyone. This has been John Engstrom. I hope that has helped. Please let us know if there's anything else we can do for you.